Now let's look at p-chart. In some cases, system performance can be classified as either good or bad, or sometimes we say success or failure, pass or failure. Primary concern is the percentage of bad performance or percentage of students who fail the class, the percentage. So whenever we see percentage, we want to use a p-chart. So we use p-chart to monitor such a process. Here's one example. It's about insurance company. So the insurance company want to design control chart to monitor the process. They want to know how many claim forms are being processed correctly or incorrectly. To start the process, the company collect data on the number of incorrectly completed claim forms over the past 10 days, as shown in the following table. So on day 1, they collect a sample. So how many data points? They collect 20 data points. They inspect 20 claim forms. So out of these 20 claim forms, 3 forms were incorrect. Okay, so 20, so 3 out of 20 were incorrect. Then on day 2, they collect another sample. Again, sample size 20, so they did 20 data points, and 2 out of 20 were incorrect. So in this example, we had 10 samples. Okay, each day is 1 sample, 10 samples. Sample size is 20 because sample size basically means how many data points you have in each sample. So every day I collect 20 data points. So this is given information. So given such information, we need to construct a p-chart. So how to do this? We have 3 steps to follow. So first of all, step 1, we need to calculate the percentage of failure. Or in other words, in this particular example, we need to calculate the percentage of incorrect forms for each sample, which is P. P is the percentage. So for example, look at sample 1. I collected 20 data points or 20 forms. I inspected 20 forms. 3 of these 20 were incorrect. So I want to know what is the percentage of failure. Okay? What is the percentage of incorrect forms? I want to calculate the percentage. Okay? So this is not percentage. We want to calculate the percentage. So percentage is pretty straightforward. It's 3 out of 20. So 3 divided by 20 is 15%, or 0.15 for the first sample. We do this for each of the 10 samples. So for sample 2, it's 2 out of 20. So it's 0.1, 10%. For sample 3, it's 4 out of 20. So it's 0.2, 20%. For the last sample, it's 4 out of 20. So it's 20% or 0.2. So step 1 is given sample size, given the number of incorrect forms, we calculate the percentage of failure for each sample. So this is not difficult, but it might be a little tedious if you have a lot of samples. Step 2, to calculate the average percentage of incorrect forms across all samples, so p-bar. So in step 1, we had the p for each sample. In step 2, we need to calculate p-bar. So what is p-bar? P-bar is that we know bar means average. So p-bar means the average of all the p's. So in other words, the average of these 10 numbers. So average all these p's. So this is p-bar. So p-bar, we take average of these 10 numbers, 0.15 plus 0.1 plus 0.2 all the way to 0.2 divided by 10 because we have 10 samples. So p-bar in this example is 0.18. So this is step 2. Step 3, we want to construct the p-chart. We know for any chart, for any control chart, we need a lower control limit. We also need an upper control limit. So we have for p-chart, we have a special formula we can use. So for upper control limit, for lower control limit is equal to p-bar. So p-bar is from step 2, plus minus 3. So remember, this is always 3, okay? Regardless of any specific example, it's always 3. So p-bar plus minus 3 square root. And inside the square root, we have p-bar times 1 p-bar, and then we have n. N is sample size. For this particular example, we know sample size is 20. Yeah, sample size 20. So with the given formula, we plug in all the numbers. So P bar is 0.18, and 1 minus P bar is 0.82, sample size 20, and 3 and 3. We do the math, we'll get lower control limit, negative 0.0777, and upper control limit 0.4377. So be careful. So when we see a negative low control limit, we make it 0. Okay, that's something we need to do. So calculation-wise, it's pretty straightforward. We just apply a given formula. But once we have the number, make sure if you see a negative low control limit, make it 0. Okay, make it 0. So that's all we do to construct a p-chart. Now let's look at an exercise question. This exercise question is from the book as well. This is about a blood work. Okay, it's a laboratory. So for this particular example, we collected data on 20 days. So day 1, day 2, day 3, and then day 11, 12, all the way to day 20. So we had 20 samples. So each sample, we collect 100 data points. Okay, 100 data points. So sample size is 100. So out of 100 data points, we want to see how many of them were incorrect. We had incorrect analysis. So for example, if you look at day 1, we collect 100 data points. So out of these 100 data points, 8 of them were incorrect. On day 2, we collect 100 data points as well, and 3 of them were incorrect. So these numbers, this column and this column shows the number of incorrect analysis. So this is given information. So based on this given information, now we need to construct a p-chart. So let's follow step. Step 1, calculate the percentage of incorrect forms for each sample. So we need to calculate the percentage for each sample. So for this, because the sample size is 100, so it makes calculation easier. So for example, for day 1, the percentage is 8 divided by sample size 100. So it's basically 8% or 0.08. For sample 2, 3 divided by 100, it's 0.03 or 3%. For sample 3, so 1 divided by 100 is 1%. So we do calculate the percentage for each sample. Step 2, to calculate the average of the P. So P bar, we need to calculate P bar. P bar is the average of all the P's. So here, how many P's we have? We have 20 P's because we have 20 samples. We want to calculate the average of these 20 numbers. So you can take average. It's a little bit tedious. So add all these 20 numbers divided by 20. This is the average. So average is 0.038. So that is the average. So P bar. Step 3, construct the p-chart. So how do we construct a p-chart? We need to determine the lower control limit and upper control limit by using a given formula. So for the p-chart, this is the formula to use. Okay. So look at the formula. We need 2 numbers. P bar. We already have P bar from step 2. We also need to know what is N. N is sample size. So for this particular example, sample size is 100 because every day we collect 100 data points. So once we know P bar and N, we can plug in the right number and we can do the math. The lower control limit is negative 0.019 and the upper control limit is 0.095. As we discussed, if we see a negative lower control limit, we make it 0. So that's why the actual lower control limit is 0. It's not negative 0.19. Okay, so 0 between 0 and 0.095. So this is how we do it. Okay, this is a exercise question.